How IPsec site-to-site VPN tunnels work. Before we send a packet out on the big bad internet, we may want to give it some protection, and to do that we can use IPsec. In this MicroNugget, you and I will take a look at the concepts of how it works. We'll also take a before and after picture with a protocol analyzer to take a look at the details of what actually happens to a packet after it's encrypted. I'm excited about you joining me. Let's jump in. Let's say that you and I work for small to medium-sized companies, and this will be the company I work at here on the left, and you can work at the one on the right. If you feel really strong about it and you want to work at the one on the left, that's fine too. We can swap. So one day, our bosses, the owners of the company, decide that they want to have a merger of the two companies. And there'll be one company with two sites. And they say what we'd like to do is have full data networking between the two sites, between any servers and resources at either site. And they'd like us to do it. So how do we do it? Well, one answer is we could leverage the internet. If we have high-speed connectivity to the internet from both sites already, why not logically just create a bridge across the internet to forward our traffic? I say bridge in a loose term, a conduit as a mechanism to move packets. One reason we might not want to do it is security. If we're sending data across the internet and it's sensitive documents and data for our companies, we don't want the eavesdroppers to get a hold of it and be able to read it and understand what we're talking about. So to protect that, we could use something called an IPsec virtual private network. In this case, it would be a site-to-site VPN tunnel. If IPsec was given a microphone and we said, Mr. IPsec, tell us what you do, he would say, I do two primary things. Number one, I provide confidentiality. And that confidentiality becomes because I encrypt packets. So as those packets go over the internet, they're just ciphertext. The payload is unmeaningful. It doesn't have any meaning to somebody who eavesdrops on the data. It's all encrypted. The second thing I do is I have data integrity. Data integrity verifies that no bits have been twiddled or manipulated in transit from R1 to R2 or from R2 to R1. It also has the ability to do some amazing authentication as well. And it also just has the ability to do anti-replay support for people who are trying to play back an authentication session, for example. It won't buy into it. But the two major elements are confidentiality and integrity. So what we can do is we can leverage something called an IPsec VPN over the internet to keep our data safe. So that's IPsec's claim to fame, is confidentiality and data integrity. How does it do it? Oh, you're gonna like this one. Check it out. With IPsec, let me clear the screen here. With IPsec, it simply says the router say, you know what, Mr. Router 1, I'm going to take any traffic that's sourced from this network if it's destined to this network over here, and instead of just forwarding it, like making a route lookup and forwarding the packet, what I'm going to do is I'm going to encrypt the data to scramble it to make it ciphertext. I'm going to re-encapsulate it, and the internet's going to see a packet from my address to R2's address. So maybe this PC here is sending a packet over to this PC here. That's the actual traffic that's really happening, but the router gets it, looks at where it's going and where it's coming from, encrypts it, encapsulates it, sends it to R2, and the internet just sees 13001 going to 23002, and the payload, the original packet, is completely tucked away and encrypted. R2 decrypts it when he gets it, forwards it onto the PC2, and those two PCs had no clue what even happened. They just sent packets and they went, but we're leveraging the internet for the backbone of that communication. So that's how it does it. It takes packets, encrypts them, ships them to a peer, and the peer decrypts it. What I'd like to do is give you a perspective, two different perspectives of what those packets would look like with a packet tracer. I'm going to show you what the packets look like right here when, I'll say Bob, is sending a packet to Lois. And I'll also show you the same packet, after it's gone through R1, who has encrypted it, encapsulated it, and sending it over to R2. Just so you can see the exact same packet before and after the encryption takes place. So let's first verify the pieces. This is our PC right here. The IP address is 172.16.0.2, and we're going to ping out to this guy's IP address, which should hit the router. He should encapsulate it, send it over to R2 as an encapsulated IPsec packet. R2 should de-encapsulate it and forward it on to PC2. Though that's the theory anyway. Let's go ahead and launch it. I have the captures running, and we're setting 4 pings. Let's go take a look at the packet captures. So let's take a look at these packet traces. This one right here on the left is the packets that were captured between the PC and R1. And over here, this is packets that were captured after R1 sent them out to the internet encrypted. So let's just, as an example, let's look at the very first packet. It's a ping request, it says right here, and it was sent from 172.16.02, that's this PC, destined for 192.168.0.20, that's this guy. When that packet hit this router, it said, oh my goodness, this is a packet I should encrypt from the local network to the remote network. It encrypted it, encapsulated it, and shipped it to its peer. So this is the packet the internet sees. They see a packet from 13.0.0.1, which is the outside address of R1, destined to 23.0.0.2, which is the outside address of R2. It's using ESP, which is protocol number 50 at layer 4 of the OSI reference model. And if we look at the payload, I highlighted the encapsulating security payload. That's the protocol. Look at the contents. They are all encrypted. So the original contents was a ping request from this IP address to that IP address. The original IP headers and the content, which was the ping request, plus this padding here, where a ping can verify that it has the ability to do the alphabet, all of that's hidden and it's scrambled in this content right here. So anybody looking at the packet over the internet will simply see ciphertext. R2, when he receives this packet, will appropriately decrypt it and forward it. So the packet we would see right here on this network segment would look like this right here. The layer 2 addresses would be different. We'd have a source layer 2 address of R2 and a destination layer 2 address of the PC, but everything in layer 3 and higher regarding the source and destination IP addresses, the ping request, the ICMP, and everything else would be as if encryption never happened. So the encryption is only happening over the internet. And that, my friend, is how IPsec can protect packets as they go over that dangerous little network called the internet. In this MicroNugget, we've identified some major features of IPsec, including the ability to encrypt data to make it protected or confidential, and also to verify the data integrity of packets as they're being sent. How does it do it? It's simple. A router being configured as a VPN gateway, when it receives traffic that should be encrypted, it does the encryption, it re-encapsulates it, and shoots that packet over to its VPN peer on the other side, who decrypts it. We also took a look at what the packets would look like before they're encrypted and after they're encrypted as they go over the internet. I hope this has been informative for you, and I'd like to thank you for viewing.